These are your 4-6B notes, and they are on the quadratic formula and the discriminant. So we talked about the quadratic formula in the previous section. That's to find the solutions to actually give the values of x. The discriminant is just a section of the quadratic formula. And if you know the value of the discriminant, then you can kind of you can tell what the solutions are going to look like. Are they going to be two nice rational numbers? Are they going to be one rational nice number, two irrational numbers, or two imaginary numbers? So the discriminant is the expression under the radical sign. It's the b squared minus 4ac. Notice it's the value of the number before you take the square root. So do not apply the square root. It's used to determine the nature of the roots, and what that means is how many and what type of solutions. So anytime you see the nature of the roots, I want to know how many solutions and what type. Are they rational, irrational, complex? Is there one or two or none sort of thing? So this picture right here kind of summarizes all the different possibilities. So when you look at the value of the discriminant, now in the first column here, it's kind of complicated, so I'm going to have you write things next to it. But they're telling you, each time you see that b squared minus 4ac, that's the discriminant. And so they're telling you the value of the discriminant is greater than 0. So it's positive and it's perfect. If your discriminant is a positive, perfect number when you figure it out, then you will have two solutions, and they will be two rational solutions. Two rational solutions. And so if, for instance, here you're going to have a nice, it's actually going to hit kind of nice. It can be a fraction and it can be a whole number. It's just not going to have a square root inside it. So maybe it hits at 1, and then maybe this one's hitting at -3.5. Rational numbers are fractions and decimals and whole numbers, positive and negative. The next one's saying if the discriminant is positive, that's the greater than 0 part, but it's not perfect. So if the number underneath that radical sign is not perfect, you're going to have two solutions again, but they're going to be irrational solutions. So to give you an example, in the very first instance, maybe your discriminant is 36. Well, 36 is a perfect square, so when you take the square root of it, it's going to become a whole number. Whereas the second example, if I give you 5, 5 is not perfect. It's positive, but it's not perfect. So you will always have a square root of 5 in that problem, and that's an irrational number. So positive, perfect, two rational solutions. Positive, not perfect, two irrational solutions. Another scenario, what if the discriminant actually equals 0? Okay? So if you think about it, this is the number underneath the radical. The square root of 0 is just 0, so the whole plus or minus this radical disappears. The whole plus or minus disappears. And so what's going to happen is if your discriminant equals 0, you're only going to get one solution. And it's going to be one nice rational solution. The reason it's rational is because the radical went away. The square root of 0 is perfect. It just disappears. So one rational solution is if the discriminant equals 0. The radical just completely goes away. And then the last scenario is if the discriminant is less than 0. So if the discriminant is negative, I don't care if it's perfect or non-perfect. If it's negative, then you're going to have two complex solutions. Or imaginary, right? I know we get caught up in the complex or the imaginary. The book will say complex because you have a real part and an imaginary part, but I will accept imaginary. And then on the right-hand column, it just shows you a picture of each of these scenarios. So if we were solving by graphing, that's when it didn't touch the x-axis. We'd always say no real solutions. Well, the reason there's no real solutions is because the two solutions are complex, imaginary. One real solution was when the vertex was on the x-axis, and then two solutions. Okay, they could be nice or they may not be nice. It just depends. So let's go ahead and do some calculating here. It's really important, just like when we use the quadratic formula, that you have it in the right order. So the very first thing I'm going to do here is rearrange some things. I've got a 4x squared. I need to bring my 20x over, so I'm going to subtract 20x and bring over the 25. So I'm going to add 25. So you get it equal to 0. And then my a value is 4, my b value is negative 20, and my c value is 25. So to find the discriminant, I'm simply going to use b squared minus 4ac. I don't have to do anything else. B squared minus 4ac. So that's a negative 20 squared minus 4 times 25. That's 400. Take away 400, I believe. Yep, 400. And so this is a discriminant of 0. So my discriminant equals 0, which means I'm going to have one rational solution. So the nature of the roots is one rational solution. This is when the vertex was on the x-axis. So when you do your homework for this, you're going to give me the value of the discriminant, which was 0. You're going to show me the formula, b squared minus 4ac. You're going to plug in the numbers, substitute, and then you're going to simplify. And then you can answer and interpret what you find. Okay, the next problem, I got to bring over the 5x. So I have a 3x squared minus 5x plus 2 equals 0. And then from here, b squared minus 4ac. That's a negative 5 squared minus 4 times 3 times 2. That's 25. Take away 24. When you subtract 25, take away 24, you get a discriminant of 1. 1 is perfect. Don't forget that 1 is perfect. So 1 is perfect, so my nature of my roots is going to be two rational solutions. How many and what type? 2, and they're rational. Number 3 here. It's already in the right order. So I'm going to just go ahead and put b squared minus 4ac is equal, not equal to 0, sorry. So b squared is a negative 5 squared minus 4 times 1 times 7. That's 25. Take away 28, which leaves me with a negative 3. So my discriminant is negative 3, which tells me I'm going to have two complex solutions, or two imaginary solutions. That's pretty much a discriminant. So it's just vocab in mathematics, and knowing that number can help us. It kind of gives us some guidance as to what the solution should look like. So what I'd like you to do is tell me what the nature, describe or determine the nature of the roots for a quadratic that has a discriminant of 20. And then find the discriminant and determine the nature of the roots for that particular quadratic. Good luck.